Hi everyone, this is Mr. Younger. It's June 18th, about 8 a.m. A Thursday, and this is the last lab of the week. In fact, we actually had this week, we're only supposed to have one lab, and we were supposed to do it Tuesday, but recall that I ended up having to take a family member to the hospital, so I was unable to do it. So I just decided to stick to the original syllabus plan, which was only one lab this week, only instead of us doing it on Tuesday, which is when I was supposed to do it, we were going to do it today. So it's now been posted. It's nonlinear graphing one, and then nonlinear graphing one's addendums, what you need, and then the files that are in that week module for lab this week. I believe it's week 6. I'll show it to you in a second. But the main thing is this lab that you're doing this week, I've actually given you an extra day because the reason we only have one lab this week is because of the celebration of Juneteenth. So that sort of sets off our whole schedule, especially during the summer. It's problematic. So we chose, since June 19th is a holiday, to not have anybody have a lab on Thursday or Friday of this week. So what I've done in response to that to make sure that everybody gets a reasonable vacation time, if you will, for Juneteenth is I've only made one lab this week, and I've set it due not to Thursday at 11:59 p.m. next week, but rather to Friday. So I've given you an extra day, and of course you still have the fact that you didn't have to do the lab from Tuesday that I had told you I would try to get done Tuesday night or maybe Wednesday. That just I just decided not to do that and to do this instead this week. So let's go ahead and get started by sharing my screen. I need to first get to the appropriate screen. Now I'm going to share it so you'll know what lab we're doing. Uh, Here it is. So this is our course module, as you can see, and you see our practice test. By the way, there's an online test due this evening at 11:59 p.m. So make sure you get that done. Uh, I might change it to be due at 2 a.m. If I did, that's again just in case someone starts it at noon, at midnight, just at like 11:59. If you start at 11:59, I'm not sure Canvas lets you continue finishing your test. So by putting the due date to 2 a.m., that was just to allow you the certain number of hours on the face-to-face test to get it done. So I might do the same thing for this online test. I'm not really sure, but the main thing is you have to have it done today. So get it done today. Ideally, finish it before midnight, but definitely start it before midnight. If you start it before midnight and it cuts you off, just let me know, and then I'll give you another chance to do it. So you can see right here, June 18th. This one's due. That's online test 2 on tests on chapters 3 and 4. Of course, we also have online test 3 that's due June 28th, which is 10 days from now, and that's the last one before we do our face-to-face test. So that's more consistent with what our second face-to-face test will be, which is probably 1 through 6. I might even fit in another. We'll see when we get the practice second test practice. Actually, I have it right here. Yes, I already did the face-to-face test. Was going to be chapters 1 through 7. So yeah, that's the last. That online test 3 is the last one you're going to do prior to the final. I mean, the second face-to-face test. But the second face-to-face test, as you can see from this practice right here, is just chapters 1 to 7, not just 6. Okay. So we have that. There's where the online tests are. Here's where the face-to-face test will appear, and you can see we've only had one so far. Uh, this is often where I put the proctored final exam. I haven't put that there. Again, proctored for us this year means you have to take it with Respondus Lockdown Browser and with Respondus Monitor. So you need a webcam. You have to follow all the instructions as listed in Respondus. That means normally you're going to have to use your video camera to film your workspace area while you have the workspace area with all the pieces of paper that you're going to have out. You want to film all that and then film like down where your feet are, everything that you can reach, everything you can lunge for to reach. You want to make sure you film that. You also want to show me that, for instance, you're in a room that's closed off from other people. That would be helpful. I mainly just don't want you working with someone else in the room. That would be a problem. And in fact, if we find there's another person in the room, then while they're doing that, and there's any, well, I'll just say if we find another person in that room, that could be grounds for me to consider it cheating. So don't do that. But the main thing is make sure you follow all those steps. So if we press on, there's lab one, week 1 lab module. We're now in, as I said, week 5, which is June. This is supposed to be June 15th to June 21. I don't know why it says June 14th, but I'll fix that later. Anyways, the lab that we're doing this week, I've got it labeled as week 6, but it's actually week 5. So here's the lab, sequence 1, lab 7, nonlinear graphing. I'm not even confident that's the right number. I have to check the previous labs to adjust it. It might be changed to lab 6, or it might be changed to lab 5, or whatever lab it is. But the main thing is still nonlinear graphing is the lab we're doing. This is where you'll turn it in. If I actually find some old comments, I'll post them here as well, so you can look at those comments before turning in your lab to make sure you didn't make any of the common mistakes students make. But let's just start off by going through these documents. You do see this is a video link that shows you part of the lab that we're doing, so you'll definitely need that. This is time versus distance graph. Uh, that we're using as well. So let me open up the sequence 1, lab 7 nonlinear graphing document. Might take a couple seconds, but that's what I want to show you. I want to make that as big as possible since I'm talking to you guys. So you can see normally this lab would require an air track, a blower, a glider, wood block, photo gate, 2 meter sticks. All that stuff would be what you'd be using if you did it in the face-to-face class. Well, in this case, we're actually doing an online lab, and we've given you an addendum to this document that allows you to do it without all that equipment, but to do it from home. So you can imagine, some of the video or some of the stuff that we give you would be videos showing what we did, and some of the stuff we give you might be data that we used, and then you're supposed to analyze that. The theory is when investigating any phenomena experimentally, a number of variables cannot be identified that might affect the outcome. In many situations, the functional relationship or equation is already known. In other cases, it may not be known, and the object in the investigation is to establish the equation experimentally. The data is gathered and then graphed, and the graph is not a straight line. Then it's difficult to write an equation of the relationship directly. If it's possible to modify the way the data is graphed in order to produce a straight line, then the equation can be written uh, that way. So, for instance, if you make a plot of period of the planets versus semi-major axis of the planets, you're not going to get a straight line. If you do the period on the vertical axis versus the semi-major axis squared on the horizontal axis, that's not going to give a straight line. If you do the semi-major axis squared on the horizontal axis and the time linear or to the first power on the vertical axis, that's not going to make linear. In fact, ultimately, it was discovered that it made a linear graph only when we put the square of the period on one axis and the cube of the semi-major axis on the other. And by doing that, they gave us a straight line, and that told us Kepler's third law, which says the square of the period is proportional to the cube of the semi-major axis. And of course, if you use units of years and for period and units of astronomical units for semi-major axis, then that equation is literally t squared equals 1 with the appropriate units times a cubed. So, and you know that's got to be the case because we know, for instance, the Earth is one of those planets that obeys that rule, and the Earth has a period of 1 year, and 1 year squared is 1, and it has a semi-major axis of 1 astronomical unit, and 1 astronomical unit cubed is 1 again. And then, of course, the number 1 with certain units will make the left-hand side, which is t squared, equal to the right-hand side, which is a cubed. So that's one of the ways you can do these graphs that do not come out linear to make them linear, and then you could use back before we had computer access to computers, it was a lot harder to generate well-crafted linear fits, but we could do it, or non-linear fits, I should say. But we could do it pretty easily with linear, as we've shown you here. You can actually make a lab or make a data table up yourself by hand, draw a hand-drawn line of best fit, and it actually comes remarkably close to what a least squares fit will do. So that's what we're trying to establish for you folks is to realize that you can raise different variables to different powers and then graph them until you get something that looks like a linear graph, and then you can use the least squares fitting for linear graphs. Of course, Excel and other programs do allow you least squares fitting for other functions. It's just a lot of times those other functions are not very well suited to non to curve fitting, just because, for instance, in some cases you might make the error go exponentially large if you use one type of function instead of a linear function. So that's why that's stated here. You can see this is, for instance, one graph, and then they're telling you basically we're going to use the intelligent guess strategy, which is you assume the variables have certain powers, and normally the exponents would be a one or two or one half or one third or three halves, just some very straightforward examples. We've just been lucky enough in nature to learn that most of the experimental results we get are in support of functional relationships with only those exponents. It's really odd that we don't have, the random 0.328 exponent. We don't have 0.328 as a normal exponent necessarily. But the big thing is, it turns out much more likely in reality most of the functions we found in life, if we're trying to create those, they have powers of our exponents on the variables that are either one or two or three, meaning whole numbers, or very specific fractions like one half or three halves or five thirds, something like that. So that's what we're going to be doing in this lab is basically trying to notice how this one clearly, if you put a straight line against it, you can see that it's above the line, then above below the line, and then above the line again. And that looks like a little bit of a hyperbola or a parabola or something like that. So that's your indicator that this is not a linear graph. So what you then do is instead of graphing whatever variable had here and whatever variable you had here, you might have graphed that same variable that was here, but graph it squared or cubed or to the one half power or one to the one third power. Or you might have done it with this axis over here. Whatever variable was here, you raise it to the two power, the three power, the one third power, or the two thirds power, or three fifths power, or whatever. Whatever those variables and exponents you used were, once they made a linear curve fit, then you know the equation is whatever variable is plotted up here equals m, the slope, times whatever variable is plotted here plus b, the intercept. So the intercept, of course, is where this linear fit would hit the y-axis. But again, that's the only difference. If you had plotted, for instance, y to the 18th power and x to the 12th power, it'd be y to the 18th power equals the slope times x to the 8th power plus b. All right, as they tell you, these are the examples. The standard deviation is referred to a graph as the y variable versus the x variable. That's the standard. I don't know why I said standard deviation. I think I said deviation, but the standard convention is to refer to graphs as y variable versus x variable. So when I say y versus x, that literally means the first word in that structure was the vertical axis, and the second word in that structure after the after verses, is the horizontal, or what we call the independent variable. The y values, or the vertical axis, is always the dependent variable. So here's various comparisons they give you, and here's the data table that you can fill out from videos and stuff of that sort. So here's Kepler's law as well. Again, you can find whatever powers are going to be there. And notice they've given us all the data. The only thing is we're actually supposed to consider the t raised to various powers, or in this case, we're supposed to consider the r raised to various powers. And in Kepler's law, we're going to say the r is raised to various powers as well, all of which we're trying to get ultimately a linear graph out of. So what your job is to, try different exponents until they work. And what I would like to see is each one of these, you should show me one graph and data that didn't make a linear curve fit, and then the one that you actually decided was the best one for making the linear curve fit. I want that graph and that function too. So you're going to do that with the objects in accelerated motion. You're going to do that with the electrostatic static attraction, and you're going to do that with Kepler's third law and with the orbital velocity. Here is the experimental data part where you use the inclined plane. Again, this stuff, these actual procedures are things that you can't do because you don't have this air track, you don't have this glider right here, you don't have this flag to put on top of it, nor this light detector. Basically, it's a photo gate that basically once this little flag blocks it, it starts timing, and then once the little flag stops blocking it, it stops the timing, and from that you can determine things like its velocity and stuff of that sort. So this is the data you're going to fill out. You've already seen the video that I posted a link to, so you can find that. And again, in this lab every semester, your job is to fill in this document that we're looking at right here. I started grading lab reports, for instance, and I noticed about four students just turned in their graphs and their function. None of them followed the instructions, which was explicitly stated to take this document, answer every question that it poses. So if you see a question mark, like right here, here's a question mark. What you're supposed to do is click to the right of that question mark, hit return, 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 and then go in the middle of that white space and type out the answer. Okay. Some of the questions might be rhetorical. If you think they are, then you, in principle, shouldn't have to. But if you really are not completely sure, definitely answer the question. But you do answer every question it poses. Every blank it asks you to fill in, you should, or every blank you see means you should fill it in or say not applicable, but you shouldn't leave them blank. You also got to remember you cannot use any fonts that are typed unless they're a color other than black. So, for instance, last time in the first grading, I noticed a lot of students had they had graphed they had graphed the function and showed the data table, but you could tell it was a screenshot because it had the little border from the Excel document and stuff like that. So that was your only lifeline. The fact that it had that little messed up thing to the side that showed me it was something from Excel. That was the only reason why I didn't actually take off points for you using typed black font, because I could tell that it had been posted in here as a screenshot of Excel or some other program that I recognize. So that was literally the only reason you didn't lose points for that. So it might be best, even if you're working in Excel, to go ahead and change the colors of the font to something other than black, so that when you even post a photo of Excel, it even if you don't show the border, which you didn't mean to show, more than likely, you still can show the data and it'll be a different color and I won't have to take points off of it. So keep that in mind. No typed font in this lab report when you turn it in. None of it should be black, because that is my technique to determine what parts were added to this lab by the student versus what parts are already in the lab. So all the black font, as you can tell, is clearly part of the lab, and anything you insert that it wasn't part of the lab, I need that to be either an obvious handwritten thing, or an obvious photograph of a handwritten thing, or it needs to be typed font that is a color other than black. So make sure you do that. I don't recommend the fluorescent greens and yellows and stuff like that. I don't recommend yellow at all. Green could be okay, but I would like it closer on the dark green or hunter green end than the lime green or fluorescent green. Blue is a good color. Medium blue, dark blue, as long as it's clearly different from black, is fine as well. But anyways, as you're going through the lab report, as I told you, you have to fill in all the blanks, you have to answer all the questions, and every single calculation you do, you need to show me one sample calculation of that type of calculation. So if you, for instance, in a lab report had to calculate the average of, let's say, a width, but later you had to calculate the average of a length, and later you had to calculate the average of a height, and later you had to calculate the average of a mass, well, guess what? Because those are all average calculations, you only needed to show me one of them, and that would be acceptable. Okay. But in general, every type of calculation I need to see, even if the lab manual doesn't ask for it, I need to see a sample calculation for that. Not only that, I expect you to put all the graphs right where they ask you to make them. So, like in the procedure area, that would be fine. Or you can do in the analysis area, because that's often where you end up making the graphs and answering questions and stuff like that. So you can put the individual graphs that you're asked to make, like in this case, you can put it right below this. So I'd literally like hit click next to this blank right here, hit return, 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 and then right there in that space above electrostatic attraction, you could put not the data table, because that's already filled in here, but you could put the graph right there. The other option, of course, and this is open to you, the other option would be down here when we're doing Hold on, hold on. Uh, this isn't a good lab to explain that, but normally you would have a section where it tells you to analyze the graph and stuff like that. That's not part of the procedure. I'm trying to see if maybe this is the part that I'm talking about. Yeah. So this is experimental data. So this is the other option you can put it in, or one of the other options you can put it in. So it either needs to be in here where we tell you how to analyze the graph. You need to put the graph right there next to it, or you have to put it right where the data table was that you used to make the graph. One of those two choices. The main thing is I don't want to see at the end of your lab a bunch of sample calculations and a bunch of data tables and a bunch of graphs. That does not allow me to easily see what part it goes to. So I need the actual sample calcs, I need the actual data tables, and I need the actual graphs that you use. I need them put exactly where they're called for in the procedure or in the analysis section. So make sure you do that. Once you've got all that stuff in, you've answered all those questions, you've made sure all your fonts are not black and type text and so on and so forth. You're going to save this Word document with your maybe your first initial and your last name in the title of the document, as well as the Lab 6 or nonlinear graphing, NLG, or something like that could be in the title. And then once you've saved that Word document with your name and the lab name in it, then you're going to save it as a PDF, and that's what you're going to upload to the turn-in area for the lab. Okay, that is proper procedure, and it says it on the intro to lab, basically the area where you turn it in. There's a text area there, and that tells you exactly the stuff I'm saying right now. So make sure you read that every time, so that don't make mistakes. So I'm not enjoying giving students 50s and 60s for just completely not doing the lab the way the instructions instructed. So, anyways, that's what's going to go on with this lab. You've now seen all the different parts we're going to use, pendulum versus length, and so on and so forth. Now I'm going to go back to the module and show you the addendum so you understand what you're going to do with that. I might be able to find a video where we initially introduced this lab during COVID. If I do, I'll post that in the week module as well for the lab. So again, we're on week 5 lab module, even though it says week 6 right there. So now I'm going to show you the addendum. That was the document we just looked at, was right there, and this is the addendum. As you can tell, this is an actual Excel document of time versus distance for the nonlinear graphing 1 lab. This is a video of us taking the data that was required, but here's the addendum I'm shooting for. And remember, this is where you turn it in. Right now, it doesn't have the instructions because I just posted it, but I'll have the instructions probably about 10 minutes after I shut down this video. So let me look at the addendum. You can see, watch the video to see how the data was gathered for the inclined plane. So that's the video that I just finished pointing out to you. Complete this lab as specified in the lab book, but use the data below for the inclined plane. You will then use PHET simulation to gather your own pendulum data. So you're going to go over to PHET, which is this link right here. But if this link doesn't work, sometimes there's problems with it. Then just type in PHET and they'll pull up the website, and then you look for the simulation of the pendulum lab. But there's the data for the inclined plane. It says click on the link above, then click on download, and finally click on intro. Leave the location as Earth. No friction. The mass is 1 kilogram. Replace the 1.20 meter data point with 0.20 meters, and gather data for each length. Click and drag the mass at the bottom to 10 degrees, then release it. It will begin to oscillate in the lower left-hand corner of the screen. Click the stopwatch, and then you'll have one to take your data. So you're determining the period, for instance. The button on the lower right starts and stops the stopwatch, and the button on the lower left resets it back to 0. For each length, time 10 oscillations, then do it twice more. Find the average of these 3 readings and divide by 10 to find the period of 1 oscillation. Now that you have gathered your data, continue with the analysis as indicated in the lab manual. So that's the entire addendum. That's all you have to do to make this lab actually work. And that's pretty much it. So I don't recall us making a separate video, but like I said, if I do have a video introducing you to the lab, I'll post it here in week 5 lab module as well. And while I'm saying that, I'm going to go ahead and change this to week 5 lab module for unless I forget. All right, so that's it. I had thought maybe some people would show up for this. Remember, this is also a bit of an office hour for you guys. If anybody can ever make it at the 8 o'clock slot on Tuesdays and Thursdays, not only do I introduce the lab, I take questions about that lab, but I also take questions about syllabus, about the lecture, about problems that you had in homework, problems you had in practice tests. I can just, do it like an office hour. So by all means, make use of that. And then I want to also announce that I know I've sort of let some people linger. I sent an email out last beginning of this week, letting everybody know, or maybe it was last week, sorry, but letting everybody know that a couple people had actually missed the first face-to-face test. Uh, because I've been a little bit behind, I've got some personal things going on here, and it's maybe not be able to keep my schedule as well as I'd like it. So because of that, I'm actually going to allow you guys to take the online test, or excuse me, the face-to-face test one that you missed. I might take off, normally I take off at least 10 points for people doing it late. In this case, I might take off as little as 5 or 3 points, or I might not even take any off just to be nice. But either way, I think it's nice of me to allow you to take it because normally if you miss a face-to-face test, you're just dropped from the class. So just pay attention to your email and announcements on Canvas because that's where I will announce the test. My plan is to well, first I got to make another one and then to open it on a specific day, like Saturday or a Sunday, and you have some time between 12:00 and 1 second a.m. To start it, and then sometime before 11:59 seconds p.m. You should finish it. So that's the time frame during which you're supposed to actually complete your face-to-face test. I just have to decide which day I'm going to put it on, and I'll announce that. If you guys have very specific days that you cannot make it, like if you cannot do it on a Saturday, even though I'm giving you the whole day of Saturday to get it knocked out, or if you can't do it on a particular Sunday, please let me know because my intent is to probably let y'all do it either this weekend, either Saturday or Sunday. If not, I'm going to have to push it back till the following weekend or maybe during a weekday. So if you have a problem where you clearly can't do it this Saturday, or you have a problem where you clearly can't do it this Sunday, or you have a problem where you clearly can't do it Monday, then let me know that specifically because those are my targets right now. Those are the days that I'm thinking I might let you guys take that online test, or excuse me, that face-to-face test that you missed. If you missed an online test, there is definitely going to be a penalty. But again, keep up with those. You have an online test every 2 chapters. You have face-to-face tests on very specific days as listed by the syllabus. And I'm trying to keep that strict. We're not going to change those dates at all. And that means it's supposed to be done sometime after midnight the day before and before midnight the day of. So if I say, for instance, the test is due on June 28th, that means it has to be actually started sometime during June 28th. And normally I only give you like an hour and a half or 2 hours for the face-to-face test. So it should be done on that same day as well. So keep that in mind going forward. And that's about it. I guess we've covered pretty much everything. Uh, Again, I was hoping might have some people here in case they had any questions, but sort of stalling right now and hopes that somebody come in. But I'm already past 8:30, so I don't think anybody will. So I'm going to stop sharing and call it a day. I hope you all have a good weekend. Stay safe. Remember, I did change the due date, which would normally be 11:59 p.m. a week from today, i.e. next Thursday. But because of June 19th, I went ahead and give you one extra day, so it's actually due 11:59 on a week from tomorrow. Okay? And that's 11:59 p.m. Thanks for coming, everybody. Have a good day. Bye bye.